Assalamu alaikum, welcome back to my channel. In the previous video, part A of the DB schedule, I stopped in half because I need to fill everything. So if I keep recording this if I keep recording until I finish this one, it will take too much long time, it will waste your time. So now I already filled everything, this DB schedule you see here. So I forget to put something here. So let's select this, copy. So I will explain you what I did. This is light at room 1, and the light wire we are using 2.5 wire. You can see my first video how to make lighting drawing, then you will know why I put 2.5, and I put 10 ampere breaker. So I have 5 light there, and living room and room 2 and toilet I have 5 light, and this is light filling. And also some circuit I didn't use, so I will keep spare meaning there will be a breaker, but it will be used in the future. Example, if you are fixing additional light, you can use this breaker to connect. So this one also I forget to put. So actually this one I will put 4 mm. So this is booster pump. In the row, booster pump means I believe you know this one. This is booster pump we put for to take pressure in water. So here I have sockets and some AC units, and this cooker, water heater, hand dryer and dishwasher, and some items are here, and these are the loads I have used. For the lights I use generally 50, and the single socket I have used 100 watts. The twin socket I have used 200 watts. So each twin socket will be 200 watts. It's a double from the single. So this one I didn't use for anything. So this is I just highlight it. And the water heater I use 1500 and dryer 250. So you can see here for the AC 12, cooker 45, and dishwasher 3 kilowatts, actually 3000 watts. So these units can be changed as per material submittal, meaning if you are using a water heater in the construction side, you have to make a material submittal like catalog. You have to submit to the consultant. So once consultant approve, you can use it. So that catalog will show you how much the capacity of electricity consuming power. So you can put it that one here, but here I generally put, and this is not fixed. This you have to understand. For studying purpose I put like this. So the each load have diversity factor. In my previous video I show you how to see the diversity factors. So you see here, this is the diversity factor I have already filled, and if you go here, this is the diversity factor. So general load 60%, air condition 90%, cooker 40%, water heater 30%, other 50%, others plus motors. As per as I understood, this diversity factor meaning the usage. So the usage of current, maybe you may understand something like that. This cooker doesn't work 24 hours, but light will work. But if some see you morning time the light is switch off. If you are in summer, if you are using air condition, and if you are in a rich country or if you are in a Gulf country, always AC will be on. Something like that. As per that one, this diversity factor calculated. This is that's why this one you see the percentage they given, and if you see new regulation, they have changed this one, and they will change also. So that's one not fixed. So here you see the total load here. This is 9 kilowatts and 11.950 and 9.850. So this one should be similar. So you see here, this one in here almost 2 kilowatt different, here to here almost 3 kilowatt different. It's not a big difference. Even if you can manage to balance it equally, it's okay. But if it is here 5 kilowatts, here 10, and here 15, that's problem. So it's almost 2 to 3 kilowatts different, but still it's a problem, but I will fix now. And you see here, this is my drawing. I did two mistakes. The one mistake, this one I have repeated 2 times, and this one also I have repeated 2 times. And if you see here, I have used already R9 somewhere. See, this R8 I have used, and this R9 I have used another place, somewhere here. So this should be replaced, so I have put some circle. So now I am going to use the spare here, because I have spare here which is not filled. So where I can put, just I will go to the total load. So this is how we are balancing. So I can put it in the red color and also in the blue color. So let's go for the this one, room 2, air conditioning, meaning AC. So I will copy this one. I can copy this one totally. So let's use R10. Yeah, R10 I can use it. So I will put room 2. So I will put it here, AC. I think this is water heater. Split unit is here. So this one. Let me put some freeze pan. View freeze pan. So I can see. So this is what I put. Okay, here. So let's go here. Oh, I chose the wrong place. Let's choose here. No. Go up again. Unfreeze pan, freeze pan here. So let's go R10. Here is R10 here. Yeah, this guy. So I have put it one. So here. So I will use 1200. Then the diversity vector is 0.9. So if I come here down, so this is now 10.2, now 11.950. So almost 1.5 kilowatts difference. So no problem. So now this guy I need to change. So that one will be R10. So now I here, this is how we are balancing the dB. So too many people don't know how to balance dB. This is the way. R10, caps lock, R10. So to balance the dB, you don't have to repeat same circuit. You can change circuit also. Let's say I have a higher load in the red one and lower load in the Y one. So I can make one of this one Y color in yellow, maybe yellow Y11 something, and I can balance the dB. Then we have to reprint and give it to the people who are working this. I change the circuiting number because to do balance the load. So what they will do, they will do two things. Either they will, if they didn't pull the wire, they will pull new wire. Otherwise they will make some mark in the end of the dB wire. Just they will put yellow tag something or circuiting. So the people who are making dB dressing, they will know the dB dressing meanings. Some people don't know what is dB dressing. dB dressing meaning terminating the wire, putting slugs and a gland, and just completely installing the dB with wire termination, neutral wire termination, everything. And if you are confusing with the naming, I will just go to the Google. let's type gland electrical. Don't forget to put electrical, otherwise something else will come. So this is gold gland. So it will be like this. So you see here, let's say this is the dB, the before dB, this is wire, something like that. That's a gland. There is a many type of gland. See, this is one PG gland. It's like sometimes like a waterproofing, but it is connecting to the sockets. So this is the gland look like. Let's see how it is connected. So there is a called lugs. Lugs. Another one. So this is called lugs. So lugs, see here how they connected. This is the lugs. So if you see lugs with breaker, so you see here, okay, this is breaker, the lugs, and going inside. So they will screw here. This is the lug. See how they connected here. So you Google it. If it is not clear here, you Google it. You will understand very clearly. So this is called DB dressing. They have put everything nicely. If you don't understand, you just make DB dressing. I hope it will come. Electrical. So this all called DB dressing. See, it's perfectly arranged. It's arranged. See this one. This is good. This is called DB dressing. See this wire arrange everything perfectly. And if you are working in the field, you will understand many things. So let's go for the back. Now here it's R9, so I will go to the Y because I have problem. Sorry, with the B. So let's see, we have spare in the B. Yeah, here I have spare in the B, so I will copy this one and put it here. And this is B7, so let's change here B7. Okay, so it will be here. Yes, 1200. This is 1200. I am considering everything 1 ton AC. So if it is 2 ton, it will be 2400. This is a general loads, but even it's a general load, you have to check with the catalog or the material submittal. So let's come down. So it is 10.2, 11.9, 11.05. So it's almost okay. So let's see, total load is 33.2 kilowatts. I mean total of this one divided by 1000. So and demand is 19.08. So this 19 point, if you double click, you see here this is the total of the demanded load. It's calculated. So there's the two things. As a draftman, I am little confused with some projects, because some project they go with the most of the project they will go with the total connect load, and that is correct also, because we always go for the safety. But some engineers I have seen they go with the demanded load. So my opinion, it's better with the total connected load is the best thing, because most of the project I have seen gone with the total connected load to calculate the cable and the incoming breaker, everything, because this is safety, this is risky, and I don't know why some engineers go with the demanded load. So actually demanded load here, even this is the normal using power, better to go for the total connected load. And see, I have 33.2 kilowatts. So now I am going to decide how many ampere of breaker we need for this dB schedule. So if you go to the Kahama regulation, you will find here some regulation of calculating the amperes. And the problem, I don't know where it is, which page it's available. I will try to find for you. This is voltage drop. Yes. So this is the voltage drop calculation. Also needed. I will explain you that one later. If I not explain you, please remind me in the comments. So I will make separate video for that one. If I forget, this is switch spare outlet. All the detail you can find from this book, but it is applicable for only Qatar. So other country you have to follow their regulation, but still you can use this one because only small difference you will find in the site in the other country. See here they have mentioned water heater 1500 watt or actual rating of appliance. Washing machine, dryer, dishwasher 1500 watt each or actual rating appliance. Cooker 3000 watt, fridge 300 watt, motor actual rating, air condition 1200 watt. This is what I use, and here cooker I put 4.5 because in my one of project I use 4.5, so I use 4.5, and dishwasher some project I use 3, so I put 3. This is in the normal because too many various kind of electricity outlets coming, so you can see here. So this page number you can remember, page number, I think this page number 78. So you will see how to use. So you see here 2100 watt each, one tone refrigerant. And here you see 13 ampere socket outlet 100 watt each, and the light chandelier 200 up to 500, and the normal luminaire 50 watt. This is what I used. And this is diversity factor. And where is this calculating ampere? Formula. This is the dB arrangement. You know how to download. I hope if you view my first video, meaning dB schedule part 5a, you will know how to download this book. Then you will can learn everything whatever you want. Read full, you will learn more. Now the problem, where is this calculator? You will find many calculation option in the Google, but here let me check one by one. So I will post the recording, and I will, once I found the page, I will open the resume the video. I couldn't find in this book. It would take more time. Maybe I don't know also where I'll say correctly. But you study from the beginning, and you will know. Before that one, I ought to some when I am trying to search the formula, I found something. Say here, you know how to make symbols, everything. So it's available. So I told about lux, and also it is available here. These items, some materials. What here? This is lux. See here. So if you learn this complete book, you will get a good idea. So I search also formula. Let's see formula. No. So I don't want to waste more time of yours, but I will show you how to calculate here. It's a general calculate. So let's copy this text here. So let's break X, enter. So this is the calculation. So here the KW multiply, let's use multiply this one and 1000. Okay, then there will be a polyline. Okay, then compute. There's many way, this is one of way. So we will go for 15. This is with the volts for 3 phase, but it will come under routing. So let's solve this one. Square root. Okay, then it will be a multiple with the multiple with the PF, meaning power factor, and multiple with, sorry, this is not 415, this will be 3 because of 3 phase, and here it will be 415 the volt. So let's me correct this one, and there will be here equal and equal V. So V. So this is the formula. So let's say, and I have 1 kilowatts. So this one 1 kilowatts. So let's copy the formula again. So I will put it here 1. So it will be 1 here. If it is 1, it is meaning 1000. Okay. So root 3, if you go to the calculator, okay, calculator, so excellent. So let's go to the standard. So this one 3, cancel 3, this one. So 1.732. Let's copy this one. I need calculator. It's open many time. So this is will be 1.73. Power factors depends. Some people use 0.9, some people use 0.8. I will use 0.9. Let's go for the 0 and 450. Maybe I will make mistake. If I mistake, I will do again and copy. Again the third one. Let's keep 1000, same as it is. So this one I have to multiple. Let's go for the standard. 1.732, 1.732 multiple, yes, 0.9 multiple 415 equal. So it's 16469. Let's copy this. So let's come here again. So this one, so no, I have to remove the root because I already fixed the root, and here also. So now 1000 has to be divided. Now 1000 divided by 646.902. So it will come 1.545. So here 1.545. So if you go 0 0.8, it will come different amount here, 0 0.8. So I am now going for the 0.9. So it's almost 1.5%. So as per the thumb rule, and for the safety side, we can go for the 2. That meaning, if you have 1 kilowatts, you can go for the 2 ampere. So let's say 1.445. So how many watts we have here? 33.2. So let's go 34 into 1.5, sorry, 34 into 1.54. So it's almost 52 ampere, 53 ampere almost. So how many ampere I want here? I will go for the 80 ampere. So incoming breaker 80 ampere. I will tell you why. This one 80 ampere I calculated uh, as per this one, as per the sockets and the light, everything, this load. But here you see here some sockets are available here. I don't know what kind of appliance, meaning the electrical item they will fix. But here each socket I have calculated 100 watts. Maybe they will bring 3 kilowatts item which is consume 3 kilowatts power, they will fix. So it will be high volt. So for the safety side, even they put other can be balanced, but for the safety side we will use 80 ampere MCCB molded case circuit breaker, MCCB breaker incoming. Okay, so you can check in the Google also. So let's go to the book again, and this book, it will be little boring, but for some people little interesting, but you should know how to do these things. So here no, not this one, you go here, the PVC insulated steel wire armor. Which cable you are using, that one you have to select. But this one again, as per the Kaharama regulation, if you are, meaning Qatar regulation, if you are in other country, you have to use their catalog. Also you can use the catalog of the cable production. In Sri Lanka we have Kalani cable, they have own catalog, we can check what I am going to check now, same thing you can check also there. So let's go for here, 3 and 4 core XLPE insulated steel wire armor. This cable I am going to use. Google it, you will know what type of cable it will be. If you see XLPE cable here, XLPE cable. So there is a many type, low smoke cable, this is the XLPE cable, this is 4 core, and there is some cable called MICC cable. So these are the cables you have to understand. MICC cable. There is another cable was called LFH. LFH is that, I think LFH is that cable. Actually it's LFH is that, no, not this cable. Actually LF, I forgot. Actually low smoke halogen, low smoke zero halogen cable. Yeah, this one. LSZH cable, this one. So there's many cable type here, LSZH. So this one, as per the designer, it will be changed. So as per the cable type, everything will be changed. So this one particular have it can handle 1 hour fire. You see here they are mentioning here. Check in the Google, learn about that cable. Now we will go back to our regulation. So I have there 80 amps. Then the cable are running underground. So current rating for cable laid directly in the ground. I am not directly in the ground. Current rating for cable run underground pipe or trench. So this is the correct one because I am using underground pipe. So these are the amperes 65, 84. So 84 meaning 25. Okay. Now I will not go for the 25, I will go for the 35, which can handle 100 ampere. Why? Because of the distance. See my distance, my dB is here, example, and I am planning to put my SNDB somewhere here, so I have very far. So what will happen, I can put 35 here, 35. If I have Y35, this is because of voltage drop. So there is a certain amount of voltage drop, so I keep it in, remember, 35. So if you go here, the table, crazy table, the brick problem, my problem, I forget the page number, everything. This is happen in my everyday, always I am searching. Just now I found, here, not here. This is voltage drop? No. Here. This is the voltage drop. So you see here, this is transformer to intermediate voltage drop point is 2.5. So we will come reverse. Final circuit is 4%, meaning dB to sockets outlet something. So let's consider this is another SMDB or something, and this is MB. So this is transformer, MB panel, SMDB, DB, final circuit. When you are reaching the final circuit, it should be 4% voltage drop. If this increase, let's go, if it is coming 6%, how to return back to the 4%? Just increase the cable. So how to calculate the voltage drop? Well, there is another problem. So you have to follow this formula. Tabulated voltage drop. How can I find this tabulated voltage drop? Very simple. Before that one, I have to remember the page number 37. This is the cable what we are going to use. No, not this. This one. This is the tabulated voltage drop amount. So I am going to use 35. So actually 125 because 84 amperes. So because of voltage drop calculation, I will go for the 35. I didn't do any voltage drop calculation, but for safety size I am going to for 35. But actually I am using 80 ampere breaker, so 84. This is 25, so 1.5, and I have to go to the page number 37. Yeah, it's 38 actually. Okay, tabulated voltage drop. Design current, the amperage, the 80 will be here. The length, you will calculate the length from here to here, and you will put it here length and divided by 1000. I cannot do this one because this is not actual length, but if you draw something actually, you can follow this formula. When you finally get the more than 4%, then you have to change the cable. You have to go to the other size until you get this the 4% in the final circuit. Actually not here, up to here, and it's not 4, 2.5 something. Between here we can go at to 3%. Yeah, 2.5. This is 2.5. So we are calculating up to dB. Until you reach 2.5, you have to change the cable. And keep it in, remember, this is percentage. You know how to take, I hope you know how to take the percentage, because before I did some mistake. I put the formula and it a certain amount came, then I was checking that amount with this 2.5. So it became big disaster because I didn't convert the amount, the final amount, to the percentage. So always try convert the percentage. If not coming correct, you have to change the cable if you not reach. So now what cable size I am going to use? This is the one, right? 3 and no, I think this no, yeah, this one. So I will go for the 35 cable. So incoming cable here in the DB schedule, cable size. So this is the thing. My mouse is not working correctly. 4 core by 35 to XLPE slash SWA slash PVC slash CU. So XLPE, SWA, PVC, CU plus 1 core by, we can go for the 16 to ECC cable. So for the earthing cable there is a general rules. You can go for the 4 core 10, 1 core 10 will be 4 core 25. Let's go for the table. Yeah, 4 core 16 you can go 16, 4 core 25 you can go 16 also, 4 core 35 16, 4 core 50 you can go for the 25, something like that. There's a general earthing there's a general earthing cable sizing. So 70 is 35, 95 almost 50 something. If you see some project you will understand this one very well. So 120 we will go with the 95, something like that. And if you have open one project you will know, understand clearly. Let's say here they have mentioned anything, earthing cable, earthing, read this book, you will know. I don't want to waste time. So here almost half, consider like that. If you have 120 go for the 70 or 95, something like that. If it is running 2 run, let's say 2 by 150 meaning 150 earth cable, something like that. So we calculate already the incoming breaker, we have calculated, got the cable size and feed from, let's put SNDB dash 001. So this DB schedule now finish. So I have finished Villa 1. So you can put any company logo. Let's put one company logo image. Actually I don't want to tell you this one because this is just for decorating. Insert. Where is this image gone? Sometime even you know better, you are a good professional in the software, suddenly your mind go blank, even you forget something which you are all doing maybe 1,000 times. Here see, you do 1,000 times and you forget. Sometimes it will be here, but you search everywhere. After 30 minutes you will find the pictures, find the tools, and you will think bad yourself. I don't have image. I don't know, I am like that, but I don't know what about you. Maybe you are very smart. So let's put this one. So let's say this is company logo. This is I downloaded from the Google. Okay, now just put this one db. Let's copy this one. Paste. I think I missed something in the schedule in the load. So if I miss something, you can fill here. So let's copy this one. Copy. Move to end. Create a copy. So this will be villa number 2. So same like this you will do for all the villa. So V1, V2, V3, V4, V5, V6, V7, V8. So very closer one you can go for the 4 core 25. And another thing I want to say, so you should calculate first this one. Maybe this one have lesser than 2.5, and if you go 4 core 35 here, but when you reach here it will, the cable will can be increased 4 core 50. So you have to calculate all the voltage drop. I don't want to teach you everything one, how this one, this one, this one, this one. I am showing the way you put the road and you make a building, and I will show the land, you make the building, something like that. So I show you already how to calculate everything and you make the rest. So you know how to calculate the ampere. You can Google it, there's a more easy way, this is my way. And you can go for the thumb rule, just 1.54, just keep it in your mind. Okay, I have 20 kilowatts power. What is the ampere? Just multiple with 1.54. That's why I use 1 kilowatts. So if you not remember 1.54 something, just keep it 1.6, no problem. But as per the power factor, it can be changed. So generally some area they use 0.8, so 1.745 something will come. Anyhow, you can use double. So if you have 40 kilowatts, 80 ampere. If you have 50 kilowatts, 100 ampere breaker. It's a thumb rule. If you have 100 ampere breaker, you will be 4 core 35. If you remember this one, no need to make by heart. By experience, it will come to your head. You will know how to select the cable. So maybe some people will call you, boss, I have kilowatts, 40 kilowatts breaker, total load, how much breaker I need to put. You can directly tell them, double it and say it. This is the thumb rule. Put it 80 ampere breaker. Though what is the cable will be, directly you can say put 4 core 25. And do you have a big distance? If we say I have yes 100 meter, 150, go for 4 core 35 for the safe side. So this is how experienced people talking. But this is as per the thumb rule. I hope you understand, because many people call me, they ask me, I answer like this, and it won't be wrong because this is as per the Qatar I am telling. But if you are working in other country, you have to study their rules and their thumb rule and answer for that one. And I hope you understand very well. So now here I have here 80 ampere, almost 80 ampere consuming power, and I am going for the 100 ampere. So you know, if you are applying for the Kaharma, if they ask you how much power, your total power, you have to give these schedules, so they will know how much power they have to give you. But this one should be perfect. So all the equipment what you are planning to use, everything should be here, apply here. Okay, now DB schedule finish. Now what is the next? Next will be single line diagram. If you finish see this one, then I have to select the SMDB, how much total consuming power, then SMDB to MV, maybe I have 10 SMDB, then MV to transformer. We can calculate the transformer. So I will teach you both as possible. I will teach you accurate calculation and also thumb rule calculation. So accurate calculation to get the nearest point only, but we don't use accurate calculation to buy or to make a purchasing order for the transformer or the panel or the breaker. So accurate calculation only for take it to near. Thumb rule we use to purchase the item. So this is how we will calculate. Now we calculate the dB. Then next video I will teach you how to make single line diagram and how to calculate the main dB, SMDB, sub main distribution board, and how to make purchase order. Now here you can order the dB as per this one. If you print this one and if you take to the manufacturer or if you send to the manufacturer, they will make a drawing for you and they will tell you as per this schedule what is the panel size will be. Then when they give you the manufacturing drawing for the dB with the breaker, incoming breaker, everything, something in the Google I show you before, I think it's there. Something like this, and they will give you the size. Then you can decide in your drawing where you can put the dB. Maybe this location okay or not, at this location okay or not, this one you can decide the dB. So if you have 2 3B, this is very important, dB size everything. And if it is flush mounted or surface mounted, there's too many kind of dB, you can select the model. This is how we calculate the dB, calculate the cable, incoming breaker, everything. So inshallah in the next video we will meet, we will learn